In this lesson, we're going to look at compound interest and future value, but rather than using our compound interest formula, we're going to be using the TVM Solver. And the TVM Solver is a program in our graphing calculator, so be sure that you have your graphing calculator out. Before we start in that, we're going to look at something called the Rule of 72. So let's turn our books to page 13. Now, the Rule of 72 is a formula that estimates the doubling time of an investment. 72 is divided by the annual interest rate as a percent to give the number of years. So if you know the interest rate as a percent, you take 72 divided by that, and that will give you the approximate number of years for an investment to double. So if you skip over to page 14, example 5 says, both Berta and Chris invested $5,000 by purchasing CSBs, or Canada Savings Bonds. Berta's CSB earns 8% compounded annually, while Chris's CSB earns 9% compounded annually. Estimate the doubling time for each Canada Savings Bond. So if we use our rule of 72, we see for Berta, that would be 72 divided by 8%. So you're actually putting in the 8%. This is a rare time when we're leaving that as an 8 and not changing it to 0.08. And if you do that, you get the approximate doubling time to be 9 years. If you do this for Chris, that would be 72 divided by 9%, because his CSB earns 9% compounded annually. And if you do this, you would get 8 years to double. All right, we're going to do this again. It says verify your estimates by determining the doubling time using TVM Solver. So let's go back to page 13 and see how the TVM Solver can help us do that. So for rule of 72 again, you're using 72 divided by the percent annually, and leaving it as a percent, it'll tell you how many years it'll take to double. If you're given something other than annually, we'll have to look at that question, and you'll have to change some things around to see what that means for our doubling time. And we'll see some examples like that later on in the course. All right, so our TVM Solver, what TVM stands for is time, value, money. Time value of money, really. Okay, it's the time value of money solver. So this is what it's going to look like in your calculator. Okay, so how you get that, if you take out your calculator, I'm just going to clear out what I have here. You're going to go into apps. The first one is finance. And the first one here is TVM Solver. And you'll get the same menu that we have in our notes. But what does this all mean? So below here, we're going to write out what each of these variables stands for. N represents the number of payments. In other words, that's the number of years times the payments per year. And we'll see that often. We'll have to figure that out. So this is really important. This comes up often. For I percent here, that's your interest rate. Leave it in as a percent again here. So if it says 8%, you write down 8. If it says 2.3%, you write 2.3. Don't change it to a decimal. PMT stands for payment. That's usually monthly. Now, if you have a lump sum and you're not putting in monthly payments, you're not adding to your investment. So let's say you have $1,000 and every month you want to add $100 to that, then you would put in $100 for your payment because that's your monthly payment. But if you have one lump sum that you've put in that $1,000 and you're not adding to it, then you use PMT as 0, right? That's what's over here. This PMT is 0. And then down below here for payments per year, you would put in 1. That's if there's a lump sum. So just be aware that we're not always putting a value in for each one of these. Sometimes we're going to set them to 0. FV is your future value. That's the final amount. Okay, that's how much you're going to have at the end, including your principal. PY is payments per year, so how many payments are you doing per year? So if you have one lump sum, then you've only paid it once and you're not doing that again. Whereas if you're doing a monthly payment, then that would be a 12. If you're doing semi-monthly payment, that would be a 2. So depending on how you're paying into your investment. And then CY is your compounding periods per year. So if it's compounded semi-monthly, compounded annually, compounded quarterly, that's what you're going to change there, how it's being compounded. Okay, and then make sure end is highlighted. Now we have a note at the bottom here. It says the calculator displays either a positive or negative value for PV, PMT, and FV. It's really important for you to understand what a negative value means. A negative value indicates the amount is invested or paid out by us. Okay? If we input any of the first 5 values, the calculator can solve for a missing value. Now if you wanted to solve, you're using alpha solve or alpha enter. So let's go and look at that rule of 72 question. We're actually going to do this the whole way through using the TVM solver and see if we can get the same number of years it takes to double for both Berta and Chris. So let's have a look here. So I'm going to try to have the information up at the top there. So using example 5 here, let's fill in the TVM solver. So on a test or an exam, you would write down this list and then you would tell whoever's marking what you're inputting in your calculator, and then you'll make it clear as to what you're solving for your answer. So let's start with Berta, and we're just going to write her name here so that we know that that's the one we're doing first. So reading the question, we're solving for the amount of time it takes to double. So what we're solving for here is n. That's what we don't know. Okay, I%, that is how much our investment rate is. So interest rate is, and that's 8%. PV, we can see up here, that's our present value. Our present value, that's the amount that we're going to be investing, and that's 5,000. But be careful here, you're going to put that in as a negative 5,000. Why is it negative? That's because we are investing. So negative because it is invested. That's money out of our pocket. So we're in debt, even though we're paying ourselves $5,000. PMT, well, we're not doing monthly payments. We're just putting in the one payment of $5,000. So that's going to be 0. Our future value, well, it says estimate the doubling time. So our future value is coming back to us, so that would be a positive value, and that would be $10,000. Okay, doubled. So from here to here, that's doubled. Payments per year, we're just putting in that $5,000 once, and it's only being compounded. It tells us up there it's being compounded annually. So that's what this would look like with all of the information from our calculators. So let's go ahead and put this into our TVM solver. So there always has to be a value in there. So 8, we're leaving it as a percent. PV, make sure you're using the negative, not the minus sign. 0, PV is 10,000. Then 1, 1, and end is already highlighted. But I want to solve for n, so I'm going to put my cursor back up at n, and I'm going to hit alpha, solve. And solve, you can see, is above the enter sign. Enter. And there we go. You see there's a little dot beside what we're solving for, and it gives us this 9.00646 and so on. So what does that mean? So that's our answer. So what that means is that it takes 9 years to double. Well, if you go back and check, we got the same answer when we used the rule of 72, which was much quicker. So when we're talking about doubling time, this rule of 72 is actually quite efficient. Let's try it again for Chris. So for Chris, a lot of our information's the same. We're still solving for n. I is just 9% instead of 8%, but our PV is still negative 5,000. We're investing that. PMT is 0. FV is 10,000. PY is 1. CY is 1. And then we hit end. So in terms of our TVM solver, everything's set up. We just have to go and change the 9. Go back up to n. Alpha solve. And yes, we get the same answer we got before. More decimal places, but again, it's approximately. That's rule of 72 is an estimate, approximately 8 years to, and we can confirm that using our TVM solver, 8 years to double. So we get an answer here of 8.0432311727 and so on. So that means 8 years. And that's really all there is to the TVM solver. However, sometimes you'll get questions and things will change a little bit. So you need to understand what the variables mean and how to put the data in that you're given in the question. So let's try C. There's one last part to this question. There's actually 3 parts to it. It says estimate the future value of an investment of $5,000 that earns 8% compounded annually for 9, 18, and 27 years. How close are your estimates to the actual future values? So for N, when we're putting in our years, remember N, if we go back to our notes here, N is the number of payments. So that's the payments per year times the number of years. Now for the first little while, this is just going to be the same as just putting in the value, but you're going to see how this changes shortly. So payments per year for the first one, if we just start for 9 years, that would be 9 times payments per year is 1 in this case, so that would be 1. And you can leave it as 9 times 1, or you could put it in as 9, and your calculator will do the math for you. For the first one, we're still looking at 8% here. PV is our present value. We're still investing $5,000, the same way we did for A and B. So PMT is going to be 0 because we put in a lump sum just once per year, and the compounding is also annually. Our future value is what we're solving for. So go ahead and put these values into your calculator. So like I said, if I just put 9 times 1, the calculator does the math. 8, negative 5,000, still there's 0. I'm solving for the future value, and then that's 1 and 1. So if I go alpha solve on the future value, you can see I get $9,995.02 for the amount of money, the future value, that's my principal plus my interest, that I'm going to be receiving at the end of that term, which is 9 years. Make sure you have a dollar sign when you're putting that in there. $9,995.02. So go ahead and do this again for 18 and 27 years and see that you get the same answers that I'm getting using the TVM solver. So the only thing that's changing here is the number of years. And if you look for the future value for 9 years, that was close to 10,000, right? Because it's 9,995.02. For 18 years, that's $19,980.10. And then for 27 years, that's $39,940.31. So you're having a look and seeing the only variable that's changing is we're going from 9 years, doubling that to 18 years, or going from 9 years and tripling that to get to 27 years to see how that increases our future value over time. All right, so in summary down here we can see from both lessons, part 1 and part 2, we've got our compound interest formula, right? Use exact value. For I, you're using 5% to 0.05 divided by 12, not this. So when you're putting it in as a decimal place, try to put it all in one shot. And we were practicing that, putting that in our calculator in one step. Remember to follow BEDMAS. Order of operations matters, so make sure you're using your brackets in the calculator. Know that I, your interest, is your future value minus your principal, so that's how much your interest is. Your rule of 72 works for estimating your doubling time when that rate is given as an annual rate. And this tells you, yeah, I already said that. This tells you the number of years it takes to double. Now, this formula we're doing the same thing when we're using our TVM solver, right? When you're solving your future value, you're solving for A. So we could have done each and every one of those questions using this equation as well. However, what we're going to be looking at in our next lesson is what if we wanted I, or what if we wanted N, or what if we wanted to T, what if we wanted to solve for something, or even P, other than A? Well, it's a lot harder to rearrange this formula than it is our simple interest formula. So the TVM solver, all you have to do is highlight something else that you're trying to solve for, like we did for N, right? If we were trying to find N here, that would be your payments per year times time. So that would be a lot harder to do with this formula as opposed to doing it with the TVM solver. That's it for today's lesson. Thanks for joining me.